All right, everyone, this is 4.7, congruence and overlapping triangles. Your due now is to write the 5 types of triangle congruence that we have learned so far. Okay, I'll check those when you submit. Number 1 says identifying common parts. It says what common angles do triangle ACD and ECB share? Well, here is ACD, is this triangle right here. Okay. And on the other side, we have triangle EBC. So what I'm going to do is, they ask you to separate. Okay, so obviously not the greatest or straightest of lines, but we're going to call this A, C, D. And then we have E, B, C. Okay, so what they're asking is, what common angle do the two triangles have that are in common? Well, the only one that I see is that both of them possess angle C. Okay. Now, identifying common parts. It says, what is the common side in ABD and DCA? Well, here is ABD. And then we have DCA. And if I were to label these, we have A, B, D, D, C, A. And what side do they share? Well, the only side that both of them have together is side AD. So that would be your answer, AD. Then it says, what is the common side in ABD? So here's ABD again. Whoops. A, B, D. And with triangle BAC. Well, here's B, here's A, and here's C. So this top triangle, B, A, C. So what is the common side? Well, the only one that these two both have is side BA. Okay. Okay, this time we have two overlapping triangles, and they give us two givens. That angle ZXW is congruent to angle YWX, and we also have angle ZWX being congruent to angle YXW, and those are both givens. Now, what I'm going to attempt to do is to separate these to kind of help us out a little bit. Here's WZX. Okay. And here is YWX. Okay. So what they're telling us in these two givens is that ZXW right here is congruent, okay, to YWX, which is here. Secondly, they're telling us ZWX, which is this angle, is congruent to YXW, which is this angle. Now, all we need, considering we have an angle and an angle, is a side. So if you look, both triangles share side WX. So we are going to say that WX is congruent to itself. Now, generally, I would tell you in past questions to put an X on this. And that's because it's reflexive. Both triangles share it. So what I'm seeing now is that triangle ZWX is congruent to triangle YWX or YXW. And the reason being, from what we're seeing on the right-hand side, is angle side angle is congruent to angle side angle. Now, in the past, we would have stopped at this statement, but that's not what they're asking us to prove this time. They're asking us to prove that ZW is congruent to YX. Now, once I've said that all of the triangles, or that the two triangles are congruent, okay? Once that's said, we can say that any pieces of the triangle are congruent to each other. So ZW is congruent to YX. And the reason being is called CPCTC. And what that means is congruent parts of congruent triangles are congruent. And you could see why we would prefer to write CPCTC. Okay? We're going to continue to practice with this. All right, I'm going to slide this over. We have our statements. We have our reasons. All right, the given this time is that triangle ACD is congruent to triangle BDC. And what we're trying to prove is that CE is congruent to DE. Now, that's a problem because here is ACD and here is BDC. Okay? They're asking for CE and DE, which is only a piece and another piece. Now, those don't belong to the big triangles. The triangles that those belong to are these ones, ACE and BED. We're trying to prove that this is congruent to this, okay? So, we have to use information we know, okay, to prove that these triangles are congruent. Okay, so going back to ACD and BDC. We know that they're congruent, so we can say anything that we need for these triangles here. The first one that comes to mind is that AD is congruent to BD. Hey, what's up? Yeah. No, it's all good. I'll just put them right in there. Thank you. All right, so AD is congruent to BD. And what's the reason? Well, it's the phrase we used on the last one, CPCTC. Okay, so we have AC and BD congruent to each other. Okay, what else can we use? We know that angle A and angle B are congruent. Okay, so angle A is congruent to angle B, CPCTC. Okay. We also know what? That I see a bow tie right here. Angle AEC is congruent to angle BED. And that's vertical angles are congruent. Okay, now I see angle, angle, side. Angle, angle, side, which means the two triangles are congruent. So triangle ACE is is congruent to triangle BDE by angle, angle, side being congruent to angle, angle, side. Now finally I can say that CE is congruent to ED because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay. So here we go. Here we have given that CA is congruent to CE, big sides. We have BA congruent to DE. And we're trying to prove that BX is congruent to DX. So what they're asking is for us to separate the triangles into two pairs. Well, the first pair I see is one that looks like this. BAX and XDE. And what we know is that BA is congruent to DE and that we have vertical angles here, okay, on our bow tie. Okay. Now, which is going to be useful into two pairs? So this is only our first pair right here. This triangle and this triangle. Okay. But the other one that I see is actually a little bit longer and they overlap. Okay, so it looks like BAE and DAE. Okay. So which is going to be useful when we're proving that BX is congruent to DX? Well, BX is here and DX is here. So this image would help us a lot more than the one without it. Okay. So what are we going to say? That BA is congruent to DE, which was a given. All right, fill in the missings. Number 2 is our second given, which was CA is congruent to CE. Then we're going to say that angle CAE is congruent to angle CEA. Okay, well, CAE is this giant angle on the bottom, and CEA is this giant angle on the bottom. And what's nice about that is, and this is a new term that we've never seen, is that base angles of an isosceles triangle are congruent. And the reason that we know that this is isosceles is because this entire line, CA, is congruent to CE. And if the two sides are congruent, that means the two giant base angles are congruent. Okay? Now we have the reflexive property. Okay? So what is going to be reflexive? We have AE congruent to AE. And that's the line on the bottom. Okay? Both triangles use AE, which you could see on the left-hand side over here. So the triangles are now congruent because we have side angle side. The biggest triangles. We have a giant side, we have a giant angle, and we have a side. And the same over here. Boom, boom, and the bottom. So side angle side. Then we could say angle ABE and angle EDA. Well, here's ABE, here's EDA, and we could say that they're congruent because corresponding parts of congruent triangles are congruent. Your vertical angle is your bow tie, which we pointed out before is right here and here, which is BXA and DXA. or DXE, excuse me. And we could prove that the second set of triangles is congruent by angle, angle, side. Therefore, your last statement, BX is congruent to DX by CPCTC. Okay. Your exit slip, it says identify any common angles or sides that these two might share. MKJ looks like this. And LJK kind of looks like this. So you tell me, which angles or sides do they share? They both seem to share JK to me, and that's about it. Okay, for your next one, you have DEH and GFD. Okay, and which do they share? Well, both of them have angle D. Okay. For 3 and 4, just separate those two triangles and send them back to me.